In this session, we are going to see about the basis of or introduction to the mesh analysis used for analyzing DC circuits. So, mesh analysis is going to be a useful technique to solve for currents. If in a question, if they are going to ask for finding the current through any resistor or something like that, you can use this type of analysis. Not only current, if they ask for voltage also, then we will solve the circuit for finding the current in each mesh, and then we will know the current in each mesh. From that we can calculate the voltage in voltage of any element or power consumed by any element in that mesh. Okay, basically the mesh analysis is going to provide what is the current flowing in each mesh. That is the purpose of mesh analysis. And the mesh analysis is preferred for circuits with voltage sources. So when you have a circuit, when you are given with a circuit which have number of voltage sources, then you can go for mesh analysis. But even when you have current sources, even some of the sources are current sources in that circuit, then you can use the mesh analysis. Extended version, we will discuss that. These are some of the points to remember when you go for mesh analysis in using this technique for analyzing a circuit. First we have to define what is mesh. Mesh is defined as a closed path which does not have any other loops within it. So it is going to be a closed path. It should not contain any other loop in it, and normally in any circuit each branch will have a separate current value. So the number of different currents in a circuit is equal to the number of branches. And when you use this technique, some of the current in the circuit will be independent currents and the remaining current will be depending on the independent currents. So when applying the KVL, you will be solving the independent current by using the KVL equations for each mesh in the circuit. So these are the points to remember in applying KVL. Now we will discuss some of the steps to apply the mesh analysis for any given circuit. First step is that you have to calculate the number of meshes in the circuit. How many loops are there in the circuit? As we already mentioned, mesh is a closed path which should not have any other loop in that circuit within that mesh. So how you have to calculate that is, for a given number of branches in a circuit, and then you have to identify the nodes of the circuit. You have to identify the number of branches in the circuit. From that you can calculate the number of mesh in the circuit equal to number of branches minus the number of nodes plus 1. And in step 2, in step 1 we have found out number of meshes. For each of the mesh, an independent current is going to be assigned. That is the step 2. Step 3, the direction of current is going to be arbitrarily chosen. Usually we will be choosing all the mesh current to be in clockwise direction, but you can also choose to be anti-clockwise. Usually I prefer to use the clockwise direction. All the meshes, how many meshes are there, all the meshes we will choose a current. The current direction of the current will be, for all the meshes will be clockwise direction. And step 4, for each mesh an equation is formed using the KVL. And step 5, now we will be having number of equations that is equal to the number of meshes. If 3 meshes are there, we will be having 3 equations. If 2 meshes or 2 loops are there in the circuit, then we will be having 2 equations. That is simultaneous equations you will be having. The number of unknowns will be equal to the number of mesh. If you have two number of loops, you will be having 2 unknown value of current in that equation. If you have 3 meshes or 3 loops in a circuit, you will be having 3 unknown values of current, I1, I2, I3. So you will be having 3 equations. You will solve the simultaneous equation to find out the I1, I2, I3, the mesh currents. And you can, all these equations will be arranged in a matrix form, and it will be solved to find out the values of I1 and I2, I3. You can use Cramer's rule to determine the mesh current values. And step 6 is when all the mesh currents are chosen in the same orientation. Same orientation here means that either clockwise or anti-clockwise. Same orientation means all the mesh currents are in clockwise direction. Then when you write the matrix, if you choose like this, if you choose all the mesh current to be clockwise direction, the common elements, what are the common elements is the resistances that are connected in both mesh 1 and mesh 2 are common elements. All these will be having negative values in the matrix. So when we discuss the example for this, we will be able to understand this more clearly. And before that, before going for mesh analysis, I want you to understand how mesh analysis can simplify the circuit analysis to a very small time, to small number of steps. So for that, I am going to choose an circuit that I will solve by just reduction of resistances. By when resistance are connected in series, I will add the resistance, then parallel combination, I will apply the formula, and all those current divider rule, voltage divider rule, series parallel combination reduction, all these techniques I am going to use, and I am going to solve that circuit. You will come to see that how many number of steps are needed to find the solution for the problem. Then we will go to the mesh analysis and I will apply the mesh analysis for the same circuit with all the same values step by step as given here, and then we will see how the mesh analysis can simplify the circuit analysis for us. So this is the circuit that we are going to solve by series parallel combination and current divider rule, voltage divider rule. All these things we are going to apply and we are going to solve this circuit. That is, the question asked is the power delivered to the 16 ohm resistor. We know that the power is equal to I square R. So I know the resistor value is 16 ohms. So now I want the current that is flowing through the 16 ohms. For that, I am going to reduce the circuit and find out what is the total current coming out of that 100 volt energy source. Then I am going to apply voltage divider rule, current divider rule, all those things to find out what is the final current that is reaching the 16 ohm resistor. Let's do the problem. So first we have that these 4 ohms, 16 ohms and this 4 ohms. All these are connected in series. So I am going to reduce this circuit as follows. So all these resistor combination, that is 4 plus 6 plus 4 ohms, which will give you 14 ohms. So 16 ohms, 4 plus 16, that is 16, sorry. So totally we will be getting 24 ohms. Here 24 ohms, 12 ohms, 6 ohms, 6 ohms, 12 ohms, 8 ohms. Here also 8 ohms, and you have the 100 volt voltage source. So now you can see that the 12 ohms and the 24 ohms are in parallel combination. So now again I am going to reduce the circuit by applying the parallel resistance formula. When I reduce it, I will be getting here 12 into 24 divided by 12 plus 24. So I will be getting here 8 ohms. If I solve this, I will be getting here 8 ohms, 6 ohms, 6 ohms, 12 ohms, 8 ohms and 8 ohms. Here you have 100 volt. So now you can see that the 6 ohms resistor, 8 ohms resistor and this 6 ohm resistor, all these are connected in series combination. All these are connected in series. How we are coming to the conclusion they are in series? That is, when a current is going to enter here, the same current is going to flow through the 6 ohm resistor, 8 ohm resistor and the other 6 ohm resistor. So by this I come to a conclusion that these 3 resistors are in series. So again, when I try to reduce it, so this is 6 plus 8 plus 6, which will give you again 20 ohms. So that here 12 ohms, here you have your 8 ohms and the supply voltage 100 volt. Again, when you see that, here we have a parallel combination. So again I am going to reduce it further, which will reduce my circuit to, so this parallel combination will be 12 into 20 divided by 12 plus 20, which will give me 7.5 ohms. So now I can calculate the total current to be I is equal to V by R, which will give 100 volt. The total circuit resistance is 8 plus 7.5 plus 8. So I will be getting 4.26 amps. So this is the total current that I will be getting. Now I know that this is the current that is going to come here. This is the current that is going to come here at this node. Okay, now I have to find out what is the current that is coming here. Okay, what is the current that is going to be coming and flowing through a 20 ohm resistor? What is the current? I will name this as I1 and I will name this as I2. So how I can calculate I2 is equal to total current. By applying the current divider rule, I can apply this and I can find out total current into the opposite value of resistance divided by sum of resistances, that is 20 plus 12. So I can get that I2 is equal to 1.595. Okay, amps. So now further if I go above, you can see that this is I1 and here the current is I2. Apart from the 6 ohm resistor, the current flowing is the I2, that is 1.595 amps. So now the same thing I am going to apply here. This is where the I2 comes, 1.595 amps. Now I am going to name this as I3 and I4. I am interested in finding out the current through 16 ohm resistor. So I am going for finding the I4. So I4 is equal to the total current coming inside 1.9595 into opposite value of resistance is 12 divided by 24 plus 12. So here I will be getting I4 is equal to 0.532 amps. So this is the current that is going to come and flow through here. After this is the current that is going to be flowing through the 16 ohm resistance. So now P is equal to 0.532 the whole square into the resistance value 16. So the power consumed by the resistor is 4.527 watts. So when you are going for solving the circuit by using circuit reduction by series parallel combination and applying current divider rule and voltage divider rule, this much complication is involved in solving this circuit. So to simplify the circuit analysis, we go for mesh analysis. mesh analysis of the same circuit. Now we are going to use the mesh analysis for the same circuit and we are going to solve it. Okay, so you can see the step 1. The step 1 is to find out the number of mesh in the circuit. You can see that there are this is one another branch where the current through all the elements will be same, and this is another branch, this is another branch, this is another branch, this is another branch, and this is another branch. So I can say that this is the first branch, second branch, third branch, fourth branch, fifth branch, sixth branch. So number of branches in the circuit, number of branches. To find out the number of mesh, first you have to find out the number of branches in the circuit. So we have found the number of branches to be 6, and we can identify the number of nodes as follows. You can see that here are the number of nodes A, B, C and D. So how many number of nodes we have? We have 4 number of nodes minus 1. So the total number of mesh in this circuit is 3. So by seeing this circuit itself, we can say that we have 3 meshes in the circuit. 3 meshes in the circuit. Now coming to the step 2, we have to assign an independent current for each of the mesh identified. So we identified that number of meshes in the circuit is 3. So we are going to assign current to 3 loops. So I am the third step also I am combining. I am going to assign the current in clockwise direction for all the mesh. I am going to assign one current I1, I2 and I3 all in clockwise direction. Step 2 and step 3 are followed here. Step 2 and step 3 are finished. So we have identified 3 loops. So we have assigned 3 currents to the 3 loops and all are in clockwise direction. So 3 steps finished. The 4th step is that we have to write KVL equation for each mesh. KVL equation for each mesh. So here comes. So first how we are going to write the step 4. So applying KVL to the mesh 1 or loop 1 you can say. So first we have 100 volt here. So first loop have an voltage source 100 volt. The current is coming out of the 100 volt source. So we are taking that voltage as positive. 100 volt is positive. Minus the voltage drop in the 8 ohm resistor is 8 I1 minus the voltage drop in 12 ohm resistor is 12 into the current flowing through that resistor. You can see that the current flowing in this direction for I1 and for I2 it is in this direction. So we are going to use that as I1 minus I2 minus 8 I1 equal to 0. So this is the equation for mesh 1. So when I reduce it, I will be getting 28 I1 minus 12 I2 equal to 100. This is going to be my first simultaneous equation involving I1 and I2. And second step, by applying KVL to mesh 2, loop 2. I am having the equation. First 12 into. So when we are considering the second loop, I2 should be higher. Therefore, I2 minus I1. I am writing this. You have to concentrate and look at this. I have written like I2 minus I1. 12 into I2 minus I1. And then 6I2 plus 12 into I2 minus I3 plus 6I2. All these are going to be the voltage drop. Okay, therefore no voltage rise is there. So is equal to 0. So when I reduce this, I will be getting minus 12 I1 plus 36 I2 minus 12 I3 is equal to 0. This is going to be my second equation. So for applying the KCL here, I am going to split it. I am writing here, applying KVL to mesh 3. I am getting, here I have to consider I3 as higher. Therefore 12 into I3 minus I2 plus 4I3 plus 16I3 plus 4I3 equal to 0. So when I reduce this, minus 12I2 plus 36I3 is equal to 0. This is going to be my third equation. So for each mesh, I have formed the equation. So step 5. Step number 5 is going to arrange these equations in a matrix form. Arrange this equation in a matrix form. So how I am going to arrange this is, so 28, considering the first equation, 28 minus 12, I3 is not there, therefore 0. I1, I2, I3 is equal to 100. This is nothing but it is in the form of, this is the values of resistances and this is the values of current in the circuit. These are the values of voltage in the circuit. So you can see that this is nothing but the application, the extension of the Ohm's law. That is what we are trying to do here. Now considering the second equation, we have minus 12I1 plus 36I2 minus 12I3 is equal to 0. And considering third equation, 0, I1 coefficient is not there, therefore I am putting 0, minus 12 and 36 is equal to 0. So by solving this equation, by solving this matrix, I will be getting the I1, I2 and I3. But I am only interested in finding the current through the 16 ohm resistance. The current in this 16 ohm resistance, the current that is flowing through the 16 ohm resistance is I3. So what I can do is, I will find out the determinant of the matrix first. By applying the Cramer's rule, I can find the determinant of the matrix. Like 28 minus 12, 0 minus 12, 36 minus 12, 0 minus 12, 36. So if I find the determinant, I will be getting 27,072. I am only interested to find out the I3. Therefore, what I will do is I will find out the del I3. How you can find out the del I3? I can insert the voltage matrix in the third column. So the third column is now going to be 100, 0 and 0. So this will be giving me the answer of 14,400. So to find out the current, I have to solve this by using I3 is equal to del I3 divided by determinant. So 14,400 divided by 27,072, where I will be getting I3 is 0.532 amps. So this is the current that is flowing through the 16 ohm resistance. But the question asked is the power consumed by the 16 ohm resistor. Power consumed by 16 ohm resistor is I3 square R, which will be 0.532 the whole square into 16, which will be giving me 4.527 watts. This is what we have exactly found out in the previous problem also. By considering the DC circuit analysis, this is the power that we have found out, 0.527. So instead of using all these steps, instead of reducing all these circuit analysis, when you go for mesh analysis, you can directly form the matrix and solve it simply and find out the current that you needed. If you found this video helpful, subscribe to this channel for more such in-depth concept analysis. Thank you.